Thank you. Well, my presentation is called Keeping a Sigmafine System Healthy. Basically, this presentation, well, the origin is while we were doing support to some of our clients, we identified certain set of problems. So our idea is to create something where we will help you to create some, I would say, some practices of the things that you need to check and that you need to view in your system to keep it up and running as you are expecting it to have. So the agenda first, we will start with an introduction. Then we will go and see all the details that are basically considered as the key elements to have a Sigmafine system healthy. You will need to keep in mind for the presentation that is considering your current system. We are not modifying as these are the changes that you need to have. These are the things that you need to pay attention on whatever you have today. The IT infrastructure, the different data sources, your model, how your model has to be updated, and then we will go to the activities of the daily use, and we will go something similar to what Janine showed you, how we see the quality of your model based in the DX indexes, how we check it, the type of errors that are there, and then we will take that information to feedback again to wherever we have in the set of how we can organize our information, trying to detect what are the problems and how we can solve those problems in the future. The intention of this, we know how the Sigmafine is important for you. And we know how it's a key element for you taking decision, how you validate the information that is in the system to take decision based in wherever you have to produce and the information that you are receiving. So that is how we consider how important is the Sigmafine for you, and this is actually the intention. What are the things that we need to modify and validate and check in daily basis to continue having this system in a very good shape? Well, the first thing, it will be in the IT infrastructure. Well, based in the database, in our knowledge base in Pimsoft, we had identified that almost 10% of your question, I always considered of what is the actual correct configuration that we need to have in our system. Then from that, we can also take in consideration that many of the problems that have been detected related with the system importing data is around 5.2%, the number of errors associated with importing data from your data sources. So for this, we need to, they say, one of the most important things is what is the Sigmafine environment? What is the ecosystem associated with a Sigmafine? So for that, we're considering, for instance, what we have in the ISA 95 are the different elements that we have. They say we're starting from plan scheduling, reporting operation management, the regulation compliance management. We have the maintenance operation management, and the area where is the Sigmafine solutions or the Pimsoft solutions. That is basically the inventory operation management, where we have our solution, the IMM, the intelligent movement management part, and where we have the production operation management, exactly in the area where is the Sigmafine, that we have three main areas where our system is working at. This is basically the performance management, the production accounting, and the mass and energy balance. As you can see in the overall organization of application in a system, is here what we have been talking all the morning. That is basically the different elements that we have in our plan. From the initial stages in your plan, where you have the commercial operation, what is coming, what I need to produce, and then we have our plan, our schedule, and that information is given to the Sigmafine to define the daily target. What do we have to produce? In the same way, in the IMM, we consume that information to identify what are the daily operations that needs to be done. Sometimes you have your own application to collect movements, but we have our own IMM to keep control of those movements. Information can come from the laboratory information system, but also the lab information in many cases goes directly to the data historian. That can be the IP21, it can be also SoftPy, it can be the PhD, like in some of the other sites. And then all that data is accumulated in our Sigmafine, and it's over there where we are going to do our daily analysis, collecting what are the the data sources, doing the collection of all the transfers, and the different steps for the data validation, data reconciliation, and association of data. So when we are talking about our ecosystem or our environment, is that we always need to consider that the information that is coming from the other system, it has that quality. So we need to be sure that wherever we are producing is always coming in the optimal conditions. This is one of the most important elements in our system, and we need to keep in mind that the quality of that information is really relevant to have good results. So in this sense, we can consider that the dependencies of our system is basically the good IT infrastructure from the sense of how we are, I will say the condition of memory, compatibility with different elements, the number, I will say the elements that are associated in our Sigmafine model. I remember just one question that you asked to Mariana that was related about how big is your model. So here is very much about keeping in mind that we will have a better quality according how well is modeled. Whatever it is we have in the plan, and we need to have an analysis associated to that different assets, we need to have that element in our model. Well, the different data sources that we have in our system, basically associated at all that information, it can come in some circumstances as a manual entry, or sometimes directly from a data source system that has an automated way to import that data from the field, and the cases for the execution of that information, and finally, how we will validate the results of data. In the IT infrastructure, it is important to know that it is a compromise of the different steps. Let's say the hardware specifications, the information frequency, the access to the different data sources, the size of our model, and also the compatibility of our system is a very key element in how our system works. We have seen many situations where our client calls us and they tell us, hey, my system is not working for that specific situation. Well, sometimes it's very important to keep in mind that our system as a whole has a compatibility with the different elements. And that's why they say we have been working very hard. You can see in the documentation that have been attached to whatever we have, we create this matrix that is basically how we recommend that the system needs to be installed. Sometimes I know that it's a headache deciding what are the options, whatever. So this table that we have created for you will help you as a reference when you are installing a new client. What is exactly the compatibility that is associated to each of them, and what is the correct setting that you need to have. Also, you need to remember, actually, we have a more detailed matrix of this. If you need additional information, you can consult us at the detail that Cody was telling you at the beginning, at the end of his presentation. We have also some details about what are the hardware, a specific hardware that is needed for the different elements of our your Sigmafine system. It could be if it's well for the server or for the client. Especially, I will say in this case for your client, that is what in regular basis you are creating. Well, for the data sources, this is something very important that we have found that it's in a very common sense that from 20 to the 50% of the error that you detect in daily basis is associated with the data that has been collected. I have at the end of our presentation some analysis of a certain set of cases where you can see those numbers who are displayed in the analysis. And it's basically something that is very important to keep in mind how big the number of errors that we are having is associated to the steps of data collection. And the idea is here we know that, let's say, we have certain recommendations where in regular basis we need to be updating, let's say, our file security or accounts associated in the domain, what are the passwords associated to it. And in some cases, I will say it is very common that we have those calls asking us, we are not collecting data anymore. And then when we go and we check your system, we find out that it happened that the password associated to the data collection was updated, and now it has to be modified on some of the service. So this is something that we just need to keep in mind, that every time that you do an update, that information needs to be updated directly in our system too. Well, for the part associated to the model updates, we have identified basically two things. When a model requires a big, let's say, a big change for permanent changes, like for instance, an expansion or the commission of your plan, but also the model amendment. The first part for model updates is basically when you need to modify your system, adding more elements and or probably associating new attributes to your templates. The second is very much associated to just changing the status of your element. But you really need to keep in mind that every time that you modify your model, you really follow the initial practices that you had when you create the first model or the original model. It will be taken in consideration what are I would say the first recommendation was use your development environment to install your system and check wherever are changing and override, just validate that the changes that you are doing are good. Then follow the initial guidelines from your initial model. Take in consideration the template that you have from the beginning, the original naming convention, but also your model topologies, how those topologies were done, and what is the actual connectivity that you have. Because in this way, you keep your reportings in a good shape. Sometimes it happens that when you change this methodology, then you impact directly how the information is getting reported, and then you suffer. Then the information cannot continue being reported, and you need to do changes to your report for that circumstances. Also, it's very important that sometimes we know how the equations that are associated in the attributes are, and we just volunteer ourselves and we implement directly, they say, a certain equation that in many of the cases is already part of the Sigmafine library. I have seen in many situations where our clients, they really do a very good work implementing equation for tank information systems, where later when we are validating, we find out they say, yep, it's really good what you did, but if you really use our standard equations, then you have the global variables or the global elements that modified or keep track of the information that you have in a single place instead of going to the different elements and modified in regular basis in each of the attributes that are there or were created over there. Well, another of the things that we have seen is when some of our clients have migrated from the earliest versions, let's say Sigmafine 3 to Sigmafine 4, they have a very good amount of information displayed in the layers of their process book. And here our recommendation will be try to use as much as possible our ADA tool. You can go there and see the same information and take the load of your system just down to the ADA instead of keeping it exactly over there. And the only thing that you have is that the resources that you require in your server and your client are much more higher. That just keeping in consideration this advice, no? Well, now running the Sigmafine, we know clearly that our process goes first from the collection of the elements, then the collection of the transfers, the collection of inputs, let's say collection of the elements that are all the data that regularly come from the data historian or from the data builder with the Excel add-in, the collection of transfers that can come in many ways, but in somehow they can be added manually or imported from other systems using the integration framework, and the collection and the input values updates. At the end, when we are running the Sigmafine, we need to keep, I will say this is the key moment of the system. We have been talking about the automation, but it's very important to validate that the quality of our data is up to the level where we can really have an automatic system importing and processing that data on a regular basis. So here I will say that following what Roberto was telling you this morning, to have this automated process of receiving the data and processing is very important in this step because it's the one that it will help you to automate in a very good way. But if you're detecting errors, as we will see in the execution of, well, in the continuation of the presentation, you will see how certain errors can be solved and can be, I will say, recovered automatically depending on the types of the error that we have. And there will be solution and dependent to the different type of error that are detected in the system. So in this sense, let's go first to something that it was discussed before in this morning, the quality indicators that we have from the DX0 to the DX4. Basically considering the data quality, the imbalance ratio, the correction ratio, the tolerance ratio, and the reconcile stretch. And I hope it can be readable in this way. So this is, as you remember, this is part of the results analysis that we have in daily basis. And I come here. And this is basically the result that we have in a real case. As you see, this blue one that is the DX1 is moving from 2.3 to 2.88. So this is a very good quality model in this sense. However, we can see here in the top, this is the number of adjustments that are done. So we keep this quality based in some additional work. So you can see that the efforts to update those models to keep it in certain level, it has a lot of work to be done to keep it in there. But in somehow, the most important thing is to identify what is really happening. Where are those errors from where are coming? So here is some of the analysis that we have done. It shows us what is the origin of those problems. If you see this one, the yellow one, these are the errors that are caused basically for missing data. So if you remember when we're talking about having a good connectivity to your system, those are basically reflected here. And in the whole set of data, we can see that it's almost the 50% of the problem that we are having in daily basis are associated to problem of missing data in our system. The others, I will say, this one, the blue one, is basically the gross error that are identifying some values that are coming out of range. The red ones is those values that we don't really need to fix it. Those are errors that are going from 0 to 10%. As they say from the analysis that I did, more of them are around the 2 or 3%. We have some spikes that are going up to the 10%, but those are, I will say, are associated probably 10% of the total number of errors. And the small one that is here is basically the missing transfers that the system has. And here in another way, how to show it is we have yellows are the transfers missing. The red ones are problems associated to, let me just check it in. These are for meters. These are the problems associated with meters. The red ones are problems associated with tanks. And the small ones, these blue ones, are for those elements that were in the ground status. So some of them that were out of service or in services, but they were not changed until they were detected. So basically, well, our recommendations here is first follow the installation matrix that we just gave you to keep in good health the environment that you have in your system. They say try to enforce this security recommendation that you have, but also keep in mind that changing that security settings affect your models. Affects your models in the sense that we are not receiving that information and impacting that information that is not coming. It goes with additional work to our system. Huh? The data sources needs to be continuously monitoring from the point of view that keep in mind that thing. They say regularly what we do is we have a certain set of tasks that are validating that the information is coming, basically, for instance, in the integration framework, where we can identify and notify that if something is failing, we can have that hint of information. They say let's keep also your model update. If your model is out of, let's say, is not representing whatever you have in your plan, it will affect the total set of results that you have. And you will have variations that really will affect the final result of your analysis. Use the standard libraries that Sigmafine provides to you, and support your daily analysis following the quality indexes that the IDXs give you. Well, we are open for questions. By the way, something, if you are interested in to do a similar analysis like this one, just drop me a line and I can show you how to have it. But because this is not coming directly from the system, I have to create a new association of data to really bring it out. But I can show you how you can get this information from the data that we have.